All right. So today we're going to be talking about and discussing about this exponential function graphs and transformations. Okay. Last Friday we did learn about the exponential growth and decay, right, and how to solve problems that deals with these exponential growth and decay models. Okay. Now, before we're gonna discuss all about the basics of exponential functions, we have discussed growth and decay last time and the transformations. Let's just go and do the graph first because it's easier if we have the graph, right? And then describe the features of the graph. Okay, so let's say we have these tables, right? And we're going to complete the table of values and sketch a graph of the function. So the first function is f of x equals 2 to the x. Now, let's try to remember, class. If you're given 2 to the power of x, what model is this? Is this growth or decay? Growth. So this is exponential growth, right? Okay. So we know that exponential growth, the graph is increasing from left to right, okay? But let's just plot the points. If x is negative 2, class, what is going to be our output given 2 raised to the power of x? 2 raised to negative 2.
Oh, we just put that.
The x is in your exponent this time, right? So the negative 2 is in your exponent. But what is 2 to the negative 2?
Negative 4. I mean,
That's a negative in your exponent.
oh wait, it'd be 1/4.
1/4. Remember, if we're going to simplify this, we're going to get rid of the negative by taking the reciprocal of the base. So if the base is 2, that's going to be 1 over 2 squared, which is 1/4. Okay? Now, what is 2 raised to negative 1? 1/2. And then, what is 2 raised to 0? 1. Any number raised to 0 is 1, correct? What is 2 raised to 1? 2. It's just itself. What is 2 raised to 2? 4. Okay, so we're going to plot the points. And then, so we have our graph here, negative 2, 1/4. So that's going to be right here. Should be lower. And then negative 1, 1/2. And then 0, 1. And then 1, 2. And then 2, 4. 1, 2, 3, 4. And just connect the points. Then you have this graph. Okay? This is our graph for the parent exponential growth. Okay? And then let's try our second table. So we have the base now is 1/2, right? So we know that this is, what model is this? If the base is between 0 and 1, exponential decay. Yes. Exponential decay model. Okay. So let's try to complete the table. So that's 1/2 raised to negative 2. So what is 1/2 raised to negative 2? Is 4, yes. So we can take the reciprocal of 1/2, which is just 2 over 1. So that's 2 raised to 2, and that's 4. And then what is 1/2 raised to negative 1? 2. Okay, 2. And then 1/2 raised to 0? 1. Okay. And then 1/2 raised to 1 is 1/2. And then, of course, 1/2 raised to 2 is 1/4. Okay. So we can try to plot the points. Negative 2, 4. 1, 2, 3, 4. And then negative 1, 2. And then 0, 1. So we have the same y-intercept. And then 1, 1/2. And we got 2, 1/4. So connect the points, then we know the graph is going to look like this. Okay. I just put the two graphs in one Cartesian plane so that we can compare the features, okay, for the parent exponential growth and the parent exponential decay. All right. So again, our y-intercept here is 0, 1. That's our y-intercept. All right, so let's write the features. What is the domain of these two functions? Correct. So all real numbers or negative infinity to positive infinity. And then what is the range?
Oh,
0 to infinity.
0 to infinity.
Yeah, but
It's a parentheses. Very good. Yes, because we know it's not going to touch the line or go beyond this line. This is your asymptote, right? This is your horizontal asymptote, which is y equals 0. Okay? So therefore, the range is just from 0, not including 0, so parentheses 0 to infinity. Same thing as the range of the second. Now, what is the increasing interval for the first graph, the red graph? All real numbers, because the entire graph, the red graph, the exponential growth graph, is increasing from left to right, so that means your increasing will be all real numbers. And you don't have a decreasing part on the first graph, right? So you say none. Now, the other one is the opposite, right? You don't have increasing because this entire graph is decreasing here. So you say none for increasing, and in decreasing is going to be, yes, negative infinity to positive infinity, all real numbers. Now, again, what is the asymptote for both graphs? Y equals 0. Do not write the number 0 because it's a line, so it should be an equation. Y equals 0. Okay, now what is the end behavior? So we know that if we have this symbol or notation, x arrow negative infinity, that means we're looking at the left side of the graph. And then x arrow, right? Positive infinity, that means we're looking at the right side, okay? So what happens at the left side as x approaches to negative infinity? It approaches to the line, right? And that is 0. So y approaches to 0. Now what happens at the right side? It goes to the positive infinity because the right side, so you can see the right side goes up, so it goes to the positive infinity. Now same thing with this, okay? We're going to write the end behavior of the exponential decay. Y approaches to something. So that's just going to be the opposite of our exponential growth model, right? So this is positive infinity because it goes up at the left side, and at the right side it approaches to 0. Okay, any question with this? All right. Any questions? All right, so let's go to the transformation part. I'm just going to go back to that. And then you all have this, right? Okay, transformations of exponential functions. So it's like the same as the transformations of other functions, but this time we're dealing with exponentials, okay? So the exponent, the variable x is in your exponent, right? That's ab raised to x minus h plus k, okay? Now again, a is going to give you the vertical stretch or shrink. The minus h, if that's minus h in your exponent, that's going to be to the right. If it's plus h, that's left. Then this one plus or minus k. Plus k is up, minus k is down. Simple, right? But if you have a negative in your a, meaning negative of the number, right? Negative here, that's going to be reflection across the x. But if the exponent is the one that's negative, that's going to be reflection across the y. Okay? And then again, if a is greater than 1, that's a stretch. If between 0 and 1, that's a shrink. So let's try to practice this here. Okay, so we are going to write our new function based on the description of the transformations. So give the new function produced by performing the indicated sequence of transformations in the parent function, f of x equals 2 to the x. So the given parent function, the base must be used in our new function. So if the base is 2, we have to include the base 2 in our new function. Okay, so I'm just going to write g of x because we're writing our new function. Okay, then we have a reflection, yes. Oh, okay. Oh, this is the next one. Okay, thank you. We'll just do this, and then we'll go back to the exponential regression. Okay? All right. So let's just do the first one, and then we'll go back to the regression. I think this is the other copy. All right, so we have g of x equals, what is our description? We have reflection across the x. So we have a negative, yes. And then what is the base? The base is 2. So negative 2, okay? And then translated down, left 1 and down 3. So where do we put the plus 1? In the exponent. So x plus 1, okay? And then down 3, so minus. Okay? So that should be your new function. Okay? Now, what about the second one? Reflection across the y. Vertical compressed by a factor of 1/4 and translated up 5. So let me just write g of x as our new function. Okay?
Would it be
1/4. But then, okay, 1/4 is positive 1/4. And negative x, yes, in your exponent. So, but again, we know the base is 2. So we have to put the base 2. Okay?
Where did that 2 come from?
It's from the base, from the given base.
So,
And then reflection across the y. So we're going to put negative x. Okay, your exponent will be negative. And then we have up 5, so plus 5. Make sense? Okay. Before we go to number 4, let's go back to, I think that's number, it's another number. I think I'm using the other one. So here, so that's number 6 actually here. And then we're going to do 3 to 6. Let's do 3 to 6 here. So we did this last Friday, okay, the exponential regression. So you just need to create a table and then use this one, exponential regression. Okay. So when we do exponential regression, you're given the points, the coordinates of the points, and then we're going to use them to create our equation. Okay. So remember, we have this y, and then regressed against a times b raised to x. Okay. Now, if you have a subscript 1, you have to put y sub 1 and x sub 1. Okay. So let's try to do, I'm going to do number 3 and 4, and you're going to do 5 for your practice notes. Okay. So let's do 3 and 4. Okay, pull up your Desmos here. And we're going to create a table. I think I have one saved already. All right, here. Okay. Let me look at the given. So we have negative 2 3/4. Okay, I'm just going to create the first table because I have the second and the third. Let's create the first table. Okay, so we have to do, the first column will be our x values, the second column will be our y values. Can you give me the x values here?
-2.
Okay.
-1.
-2. -1.
0.
0. 1, 2. Okay. And then what are the y values for the second column?
3, 4.
3. Oh, okay, it's a fraction. Okay. So 3/4 and 3/2.
3,
3,
6,
6,
and 12.
and 12. Okay, so we have this. We have the points. Now, I just need to create another row. It can be any row. And then just write the regression model, okay? So this one, I'm using x sub 1 and y sub 1, so make sure you know the subscript in your table, okay? So if it's x sub 1, y sub 1, you're going to use the subscript. If it's a different subscript, you're going to use x sub 2, y sub 2, so on, okay? So this is y sub 1 first, okay? Y sub 1. Regressed against, so we have the tilde, and then a, and then b, and then raised to x sub 1. Raised to the power of x1. Okay, so it's going to connect the points, and it's going to give you the a and b, right? Your a and the b. So we just need these values. All right, what is our a? 3. What is our b? 2. Any question? So here our a is 3, our b is 2. So to write the final equation, we're going to do y equals 3 times 2, the base is 2, raised to x.
So all we're doing is we're just plugging that in and finding the equation.
Yes. And find a and b to write the equation next. If the table is telling subscript 1, so you're going to do y sub 1.
5 equals.
Look at the way. Okay, x sub 1, y sub 1, so you're going to use x sub 1, y sub 1. Okay, let's try the second table.
Oh, we're done with the first.
I mean the fourth one, yeah, we're going to do number 4. Okay, so is this the numbers right for table 4? Okay. Now, again, for those who are confused about what digits or numbers are we putting in, it depends on your table. If the table states that the subscript is 2, you're going to use the subscript 2. Okay? So what you're doing, okay, I just need to close that. And then we're going to do y sub 2 this time, because the table is saying you have a subscript 2. And then regressed against ab, then raised to the power of x sub 2.
Wait, how do we know it's sub 2?
Because of the table is saying x sub 2 and y sub 2. Your table. It's just telling you that this is your second table. And so the equation should look at the second table. That's the purpose of the subscript. Okay? But if you have a different subscript, that's fine. Just make sure you use them, right? Whatever is the subscript in your table. Okay, so what are the values? A is 27 and B is 0.333, so on and so forth. But what is the fraction form of 0.333?
Wait, isn't that solving?
I'm number 5 right now.
Yeah,
We're
you're
number
doing
5. We're number 5.
I thought we're doing 5 over 1. 1 over 3.
Okay.
But we're doing 5.
Oh, you're doing 5. We're doing 4 right now.
Oh.
Okay. So again, what is your A again here? Second? 27. And then your B
Yeah, because
is 1/3.
Why does mine say this?
Because you're taking information from what x1, not x2.
and how do we know if it's x1 or x2?
It's just like whichever, like I could change these values just to x2, and I would just have to change it down here. It's just where it gets the information from.
Yes. Okay. Thank you for that, Asher. So again, your equation based on where you get the information. So if your table is saying x sub 2, y sub 2, you're going to use those subscript. If it's saying x sub 3, y sub 3, then you just change it to sub 3, right? Subscript 3. Okay. So now we can write y equals, what is our A? 27. And then this is 1/3 to the power of x. So this is our function. Okay, now here the base is 2, so we can say this is, I'm just going to write exponential growth. So we know that it's going to be an increasing graph from left to right. This one, the base is between 0 and 1. So this is an exponential decay. And so the graph is going to be decreasing from left to right. Okay? So I need you to, for you to practice, just do number 5. I'm going to give you time. I'm going to check this later on. Yes. Any questions?
We already did.
Yes, we did 6, so we're going to proceed with number 7. Okay, let's do number 7. Okay, so here our parent function is f of x equals 1/3 to the x. Okay, so this time we're dealing with an exponential decay, right? Exponential decay. Okay, so since the base is 1/3, we're going to use that 1/3 for a new function. Okay, so we have g of x equals. Okay, what is the transformation? Reflection across the x, so we have to put the negative sign in front of whatever's the base. So negative, and then 1/3 to the power of what? Right, 3, so x minus 3. So 1/3 to the power of x minus 3. Any question? Okay. So I'm going to leave this part as your practice, okay? Again, you're going to use the base 1/3 for number 7, okay? So just write this as 7b, and you're going to do 7b. Okay, any question before we proceed with the next one? Okay, so for the next part is, we're going to state the parent function, describe the transformations, and then identify the range and the vertical asymptote, as well as, yeah, we have the range, and then we use the transformations and an asymptote to find the range, right? Okay. So what is the parent function for number 8? What is the parent function? Y equals 2 to the x. Right? Why do we have to know the parent function? Because the parent function, the base, will not be included in our transformation. Because some of you will say, once you find that there is a 2 number there, you say that this is another transformation. The base is 2. It's not going to be included in the transformation. Okay? But we can determine that this is what? This is a growth model. Exponential growth, because the base is greater than 1. Now, so what is the asymptote in this new function? G of x equals 2 times 2 raised to x minus 3 plus 4. Y equals 4. Okay? Why is it y equals 4? Yes, because the graph shifted up 4, and so the horizontal asymptote will also shift up 4. From y equals 0, it's going to shift up 4. That's why it's y equals 4. So just remember this. To find the horizontal asymptote, it's always y equals k, whatever's the k value. So if the k value is 4, so you say y equals 4. So what is the range if the asymptote is y equals 4?
Parentheses 4, comma.
Infinity. Very good. There is no reflection, so the graph is going to be from 4 to infinity, not including 4, so parentheses 4 to infinity. Okay? Now, help me write the transformations. So what is the first transformation? Stretch by 2. Vertical stretch by 2. Or let's just write stretch by 2. And then, again, the 2 here is the base. We're not going to include that in our transformation. We're going to proceed with minus 3. What is this? Right 3. and then plus 4 up 4. Any questions? Okay, let's try to do the asymptote for number 9. What is the asymptote for this function? Y equals 0, right? Because there's no k value, there's no number after the exponent, so it's like plus 0. So your k is 0. So y equals 0. Okay? Now, so if the asymptote is y equals 0, and remember that there is a reflection because of the negative sign in front of the 2/3, right? So what will happen to the range? The range will flip, right? So if there's no transformation with the asymptote of y equals 0, we can write the range as 0 to infinity. But since because of the reflection, the graph will flip over x, and so the range will also flip. Okay? So that's going to be negative infinity to 0. 0 is going to be your maximum. Okay? Again, I'm just going to write a note here. Again, reflection in x changes the range, but reflection in y keeps the range the same, right? It's only for the reflection in x changes. Because we're dealing with exponentials, so if you flip the graph over y, the range is going to be the same, right? But if it's over x, then the range will flip. Yes. All right. Now, so let's write down the transformations. So what is the first transformation? Reflection. Reflection, I'm just going to write in x, or in x-axis. What's the second one? Compression of 2/3, or you say shrink by 2/3. And then the plus 6, left 6. Okay. Now, let me just write, because we're asked to write the parent function. What is the parent function of this number 9? Y equals 1/2 raised to x. That's our parent function, right? So let me write parent y equals 1/2 to the x because the base is 1/2. And what model is this? This is a decay model. Okay. I'm just going to show you number 10 because number 10, we have a negative in your exponent. And also, if you have a negative in your exponent, I can write this as negative of x plus 1. Does that make sense? Why? Because, again, this is negative x minus 1. If you have a reflection in the y-axis, we put the negative in your exponent. And it's just that this is already simplified. The negative was already distributed to the x and to the 1. That's why it's negative x minus 1. But every time when we determine the transformation, we have to put it back to the original. Okay? So the plus 1 is not, this one is not right 1, but that's left 1. Okay? Now, so what is your asymptote for this function? Y equals negative 2. Okay? Now, what is the range of this function? All right, it's a matter of choosing between what is the range, negative infinity to negative 2 or negative 2 to infinity? Negative 2 to infinity. Why?
Because it flipped in the y.
Why? Yes, it's
X.
yes, not the x. Only for the reflection in x changes the range. Because if you flip the graph over the y, the range will still be starting with negative 2 because the asymptote is y equals negative 2. Okay? So it's not going to change the range. Okay? So negative 2 to infinity. All right, so can you tell me the transformations now? Are we going to include 3 in our transformation? No. Others are saying yes. No. 3 is our base. Okay, that's not a stretch because some of you will say there's a stretch. Okay, so again, the parent function here, that's why we are determining the parent function so we know we're not going to include the base. Right? So y equals 3 to the x. That's our parent function. This is a growth model. Right? So we're not going to include 3 in our transformation. So we're going to start with the negative. So that's reflection, because that's in your exponent, reflection in y. Okay? And then again, if we put it back to the original form, that's going to be plus 1. So that's left 1. Okay? And then minus 2 is down 2. Any question? Okay. All right, so for the last part, we're going to do 11 and 13, and then you're going to do 12, okay, for your practice notes. Do you have any questions on the transformation? Yes?
Whenever you say, like, reverted back to its original form, like, for the exponent, like, why couldn't you just leave that, like, negative?
Okay. Why can we not leave it as negative x minus 1? Because if we're going to try to find the transformation of that, and you plot this on the graph, it's going to be going to the left one, not right one. Now, also, just make sure that if you have a negative in your exponent, that negative will be distributed to the first and second term, because you will have a binomial in your exponent, right? So remember, if you have, let's say, the base is 2, and then you have a negative x plus 3. Negative x plus 3. Actually, that negative is already distributed to the first and second term. So I can write this as 2 raised to negative of x minus 3. Okay? The negative should be for the entire expression, not for just the first term, but for both terms. Okay? So if you put the negative outside, this plus 3 will be minus 3.
So you're just doing it because if you weren't, like, x is y, so if you were to, like, plug it in not where the x would have.
Yes. Yes. Second? Tissues. I just have that. Okay. Any other questions? Okay, let's do this. So we're going to be having our quiz because we'll be done with the first 3 lessons. That's half of the unit 2. It's just a short unit. So we're going to have our quiz on Wednesday. So sometimes I will give you graphs, and then from the graph, you're going to identify or determine the equation. Okay? So number 11, the function graph below, g of x is transformation of this. And then what is the equation of g of x? Yes, Ivy?
You can first off eliminate a and b because they don't have the y is you don't have to subtract 3 because
Yes.
the y is
Negative 3.
asymptote of negative 3.
Yes, correct.
So you're left with b and c.
Yes.
And if you look at the y-intercept, it has the parent function y-intercept, so it's 1.
Yes.
And so it would have to be c.
Yes, that is right. Okay. Yes. So I'm just gonna reiterate what Ivy said. Okay. So the graph shifted down 3. Okay. How do you know it shifted down 3? Because the horizontal asymptote is y equals negative 3. That's our HA. Y equals negative 3. So the equation must have minus 3, right? So that's why we get rid of the A and D, because it doesn't have minus 3 in your K. Now also, Ivy said the y-intercept is just 1. In this actual graph, it's actually 0, negative 2, but when you say y-intercept, it's like from the horizontal asymptote, what is that? It's just 1 unit away from the horizontal asymptote.
Oh, so
Okay.
that's how we tell if it shifted
Yes.
left or right.
Yes.
It's by saying how far away the asymptote is.
Is from the horizontal asymptote, yes. So if it's just 1 unit away, then it's just a normal thing. It's just a normal graph. So there is no stretch nor shrink, so it's just letter C. Okay? Again, the base is 3, so that's why it's 3 to the x. Okay, it's 1 unit away. we can solve for the a, okay? All right, I can show you how to solve for a, okay? We don't have to really think of that as every time. Sometimes it's confusing because it's not really like slope because we're dealing with exponentials. So what we do is we're gonna do this. We're gonna do y equals a, and then 3 to the x minus 3. So we're gonna solve for a because we know that the base is 3 and we shifted down 3 and we want to solve for a. Okay? So we can just find any points on the graph and then use that to solve for a. Okay? Any points on the graph. So let's say we're going to use this. Okay? So what is that? This is 1, 0. So if we're going to plug it in, that's 0 equals a 3 to the 1 minus 3. Okay? I try to plug in, this is my x and this is my y, right? So 0 equals a 3 to the 1 because x is 1 minus 3. Okay? So if we solve this, this is what? 0 equals 3 to the 1 is just 3, so I can write this is 3a minus 3. And so we add 3 and divide by 3, that's equal to 1. Right? So plus 3 equals 3a. And we divide by 3 on both sides. Yes?
Or do we have to do that?
No. If you think that, if you're not sure if there is a shrink or a stretch, then you have to do this, if you're not sure. But if you're sure because it's just one distance away from the asymptote, then it's just ordinary, right? Ordinary graph. Okay? So, 1. So that's why the a value is just 1. So we may have to put 1 times 3, or we just have to put 3 to the x. Okay. If you're not sure, if you're not sure with the shrink or stretch, then you're going to solve for a. That's going to be your problem in number 13. Number 13, I'm going to skip number 12. I'm going to ask you to do this as your practice notes. And then we're going to try number 13 because sometimes we're not sure if it has a shrink or stretch. So we're going to solve for a. All right. So the function graph below, g of x, is the transformation of f of x equals 2 to the x. What is the equation of g of x? All right. So this is our base 2. So from the options, we can get rid of a and b, correct? Because the base here is 0.5, the base here is 4. All right, so that's an easy fix. So we can look at only for c and d if one of these equations are right. Okay, so what is the transformation of this graph? Down 4. Down 4. Okay, so this is our horizontal asymptote. And again, the horizontal asymptote is y equals -4. Okay, and then, so we are not sure what to use. Is it stretch by 2 or is it shrink by 1/2? So we're not sure. That's why we're going to solve for a. So Rowan said it's going to be shrink by 1/2. Okay, let's try to check. So again, to check or to find or determine the a value, we're just going to use the parent function because we know it's going to be 2 to the x and down 4, right? So y equals a because we're going to solve for a. And then the base is 2, so to the x minus 4.
Can you put parentheses around it?
Yes, you can, or you may not put the 2, the parentheses. I know that's multiplication, right? A times 2 or a2. All right. And then what point are we going to use for the graph? Let's just use this point. Okay? So what is this? This is 3, 0. Yes. So this is our x and this is our y. Okay? So we're going to put 0 because y is 0 equals what? A, then 2 to the power of what? 3. Because, yes, we were plugging in the x and y. We're plugging in the x and the y values in the equation. and then minus 4. So it's not always 1, okay? It's not always 1 for the x, okay? It depends on the graph. All right, so what is this? 0 equals, what is 2 to the power of 3? 8. And then minus 4. So I can write this as 0 equals 8a minus 4. 8 times 8 is 8 times 8, right? So I can add 4, add 4. So this is 4 equals 8a. So divided by 8. So what is the value of a? A half, right?
So D.
Yes, that is correct. You're correct.
Wait, so how on this one did you know that it was not, that it was regular without solving it?
Without, because this is the horizontal asymptote and the intercept is 1 unit away from that. Okay. Okay, look at this also, class. If you don't want to solve it, if you don't know how to solve it, look at this. What is the distance of the intercept from the horizontal asymptote? 1/2. So that's why shrink by
Will you
1/2.
be able to do that every single time?
You can do that every single time. But just to be sure, you can also try to solve for the A. Okay? Yes. Oh, you have your answers? Do you have any questions before I check your notes? So what are the numbers that you're going to do?
5.
5. So I can write this for Larkin. 5, 7, 7b. Yeah, 7b. I'm just going to see 7b. And then 12. Number 12. Okay. So practice notes. Okay, I'm going to stop.